Okay, so what we were talking about last time. So do you remember what we discussed last time?
Yes, sir.
Limit of 6. So let me recall this in brief so that what we discussed, convergent sequence. Limit of a sequence, then divergent sequence, right? So did I tell about oscillating sequence? Not. Okay, so we discuss about convergent sequence, and sequence is not convergent, then it is called as divergent sequence, right?
Yes, sir.
Okay, so all of you understood the definition of limit of a sequence. So let us recall definition again. So sequence xn converges to a number x or limit n tends to infinity xn is x, right? Sequence xn converges to number x or limit n tends to infinity xn is x. If, when we say that sequence converges to x, if what? Given any epsilon,
We consider epsilon greater than 0, we can
there
produce
is
k where such that xn x minus xn mod is greater than equal to epsilon, less than equal to epsilon for k greater than greater than equal to k.
right. So distance between xn and x is less than epsilon for all n greater equal k. Right. So the meaning of this statement is clear, or any confusion in this?
Yes, sir.
So this I can write out, further extend this. That means, so distance between xn and x is less than epsilon for all n greater equal k means what? Ki minus epsilon less than xn minus x less than epsilon for all n greater equal k. Am I right?
Yes, sir.
This is same as right. So this is same as so whatever I have written, is it clear?
Yes, sir.
So sequence converges to number x means what? Ki give me any epsilon. Whatever smaller epsilon you give me, I can produce k such that after that k term, so suppose my first term is x1, x2 and so on. After k term onward, this is a k term. K is suppose 100, then 100 terms onwards, right? So if k is equal to 100, and when I say n greater equal k, that means n greater equal 100. So what are the values of n greater equal 100? right? So 101, 102, all other numbers, all onwards. What are the corresponding terms? x100, x101, x102, x103, and all remaining terms, infinitely many terms. What condition these terms satisfy? All these terms are in this range. Their distance from x is less than epsilon. Ultimately, what does it mean? All xn are in between x minus epsilon to x plus epsilon. Right? So this is clear what I want to say.
Yes, sir.
Right. So thus, so alternative definition I can make at as it is. So thus sequence xn converges to a number x if for every epsilon we can produce k, or there is a term k term such that xn belongs to x minus epsilon to x plus epsilon for all terms onwards, k onwards. That is, xn belongs to epsilon neighborhood of x for all n greater equal k. So this is what alternative way to say same thing. But only thing is ki, have you understood the meaning? Ki, what is the definition and what this definition says? Ki, as we discussed in the beginning, ki, the terms are going towards x means what? Give me any distance from x, I can produce terms of sequence in that neighborhood, in that distance. Once I am able to prove this for any distance from x, then I can declare that the terms are going towards x. This is what the ultimate meaning we were discussing. Right, so no doubt in the definition, right?
Excuse me, sir.
Yes.
Uh, Sir, is the converse also true?
What is a converse?
If it belongs to this, sorry, if the limit exists, then it needs to belongs to this.
Yeah, so I will ask you a very fundamental question. What is meaning of definition? The word, right, so what is the dictionary meaning of definition? Right, so these are, okay, there is always confusion because you are learning this kind of things. So there must be a confusion. You should. But what is the meaning of definition? Definition, the name of particular thing, right? So, for example, uh, suppose you are going to the college, right? You said that I am going to the college. Then what happens after some time? You are in the college campus. So, what is the definition of college? Ki the campus and all these things, classrooms and all these things. So, if you are college, that means you have come to the college, right?
Yes, sir.
So same thing. When we say definition, definition means there is nothing like converse or a definition means it is both way true. Whatever is the meaning,
Okay. Okay, sir.
right?
Thank you.
Definition means what? What is the name of that particular thing? So therefore, there is nothing like converse. It is the both way. It is the same meaning, right? And therefore, the definition of limit n tends to infinity xn, right? So this is a definition of limit n tends to infinity of xn is equal. So sequence xn converges to x means what? Sequence xn converges to x means what? Limit n tends to infinity xn is equal to x. So what is the meaning of this? What is the definition of this limit? Is this the next part, right? And therefore, when we say definition, then meaning is same. If this is going to happen, we say that xn converges to x, right? So limit n tends to infinity xn is equal to x. If given epsilon, there exists k such that xn minus x is less than epsilon for all n greater equal k. And this is if and only if. That means if any epsilon we can produce k such that this is going to happen, then we say that limit is x. The limit of xn is x, or limit of xn is x means for any epsilon we are able to produce k. Is it clear?
Yes, sir.
Right. Fine. So so let us work out one more example so that we'll let xn is equal to 3n upon 5n plus 7, or whatever I should say here. Xn is equal to 2 upon 3n square. Right, this is my sequence xn. Now prove that limit n tends to infinity xn, or limit n tends to infinity 2 upon 3n square is 0. So this we want to prove. Okay, so how to prove? How to start the process? What is our claim? What is our claim? Right, this is our claim. Am I right?
Yes, sir.
That is, what is our claim? Right, limit n tends to infinity xn is 0 means by definition what we should prove. Because what definition says when we believe that limit is 0? What definition says?
Mod of xn should be less than epsilon for any epsilon greater than 0.
What you are saying is not perfect, because what I expect, given any epsilon, I can produce key. Right? If this is going to happen, then I can believe that okay, limit is this number. Am I right?
Yes, sir.
Right. So remember this. This is a very simple thing, but there is always confusion. Key limit is x means what? Given any distance from x, I can produce k such that after that k all terms are in this range. If this distance is epsilon, this distance is epsilon, this is x minus epsilon, x plus epsilon. So given any epsilon, any distance from x, I can produce k. This should be the way, right? Logically, what is the mechanism? Right? Don't forget this mechanism. So when you are going, when you are asked this question, so what should be your answer? Given any epsilon, we can produce k. K onwards, all terms have distance less than epsilon from x. Right, so logically your answer should be meaningful. Given epsilon, can you produce k? So that is what we want.
There exists a k for which
Right.
xn, mod of xn is less than epsilon for all n greater than equal to k.
So this is our claim. Right. Limit is 0, but here x is 0, right? Here x is 0. So this is our claim. Right. So once we are sure, we are clear what we are going to do in future. So what is the strategy? How should be the strategy? How to proceed?
So first we need to find epsilon, then
No need to find. Ki somebody gives you epsilon and your job is to produce k. We don't need to find epsilon. We are given epsilon. When I say given epsilon means what? Ki suppose, see, last time I explained this, what is the philosophy behind it? Means how logically what we are doing. Ki somebody ask you to prove that limit is 0 or limit is x, then you say that limit is x or limit is 0, whatever is that number. Then what the person will ask you, okay, how will you prove? That means what you will say, give me any epsilon, right? What you will say, give me any epsilon, then this is x plus epsilon, x minus epsilon. I will give you k. You look at the terms onwards, k onwards, all terms are in this range, x minus epsilon to x plus epsilon. And no matter what smaller epsilon you give, suppose you give me very small epsilon, right, very small distance from x, still I can produce k such that their terms are, after that all terms are in this range. Is it clear? What I said, is it clear?
Yes, sir.
Yes, sir.
And therefore our process starts with given. पहले कोई हमें epsilon देगा, so हम क्या करेंगे? We'll try to produce k. So given epsilon. So epsilon is now given. Whatever it, very small number, doesn't matter. What is our job? What is our job?
So we need to find
To
a
find the
k
k.
such that
K, right? And remember that this k depends on epsilon, right? Want
yes.
to produce k. See, this definition, many people find it, are confused about this definition. But from beginning, we discuss why this definition makes sense, how makes this definition makes sense. And then what is first? First, because give me, this is a way. So given depending on epsilon, such that, so k depending on epsilon such that the distance between xn and 0 less than epsilon for all n greater equal. Okay, this is a way, how philosophically we are looking at this, right? So okay, so process starts with give me epsilon. Now our duty starts, try to produce k, right? Do you understand now? Yes. So, and k depends on epsilon. Is this sentence clear?
Yes, sir.
Right. Because if you give me some epsilon, this distance, right, same distance on this side, this is x minus epsilon, this is x plus epsilon. Suppose after 10 term, suppose this is x10. After 10 onwards, all terms are in this range, suppose. But, and my epsilon is suppose 1 upon 25. For this epsilon, right, that means this is x minus 1 upon 25 and this is x plus 1 upon 25. So for this epsilon, I have k is equal to 10 and onwards all terms are in this range. But if I change my epsilon is 1 upon 100, will same k work?
No, sir.
Right, I need to choose higher k because after that, so I may get k is equal to 123. After that, all terms are in this range because my epsilon is small. Right. So distance is small and therefore I need to produce larger k so that the terms are in that range. So that's why I'm k depending on epsilon. Right? Is it clear?
Yes.
Yes,
Is
sir.
this clear? And did you work out the problems which I gave for exercise? If you have worked out those problems, then you can understand how k changes with epsilon. So If you choose smaller epsilon, you need to produce larger k. After that, terms are closer, right? Fine. So how to start the process? We want to produce k, right? So, but what type of k we want to produce? Ki the distance between xn and 0 less than epsilon, such case. So consider xn minus 0. Try to simplify this so that we can guess, right? We can guess the value of k so that that will serve the purpose, right? So we'll first try to simplify this absolute value of xn minus 0 so that we can easily guess k. So what is the next step? Xn minus 0. What is xn in this case?
2 by 3
2
and
by
2 by 3 n square. So 2 by 3 n square minus 0. It is just 2 by 3 n square because minus 0 is same value and it is non-negative quantity, right? Now, can I say that this quantity is less than 2 upon n square? Am I right? Whatever is n,
Yes, sir.
because I am reducing the value of denominator. So denominator is smaller, so the amount is right. Okay, now you tell me, just think about it. You tell me how to guess the value of k from this last expression.
We'll write 2 by n square less than epsilon.
So observe that, right? There is some observation. You have to observe, you have to use your intuition. Observe that xn minus 0 can be made less than epsilon if. This is our aim. We don't know how to make this, but if you want to make this quantity less than epsilon if we make some larger amount less than epsilon. Am I right? Right? If you are successful to make larger quantity less than epsilon, certainly smaller quantity would be less than epsilon. Am I right?
yes,
sir.
So this is my logic. In my mind, what is in my mind? I want to make xn minus 0 less than epsilon. This is in my mind. But I got something different. So xn minus 0 less than 2 upon n square. And now I understand. If I make this larger amount less than epsilon, certainly this xn minus 0 would be less than epsilon. That I understand by this observation, right? But 2 upon n square is less than epsilon if n square is greater than
2 upon epsilon.
n square is greater than 2 upon epsilon. That is if right? Is it clear?
Yes, sir.
Okay, now you tell me what should be our first guess. What guess we can make from this to the value of k?
K should be greater than root of 2 upon e. K should be greater than root of 2 upon e.
Choose k natural number greater than root 2 upon epsilon. Is it well defined thing? Is it well defined? What do I mean to say that well defined? If somebody told you to um, make some uh, food item, for example, somebody asks you make ice cream, how will you do it? You will ask, give me some raw material which is required to make ice cream, right? If there does not exist such raw material, you cannot make ice cream, right? So this quantity k is well defined. We can certainly produce k if the 2 upon root epsilon, 2 upon epsilon is the known quantity. Do you know 2 upon epsilon? Is it known quantity?
Yes, sir.
No, sir.
Yes, because what we started with epsilon. Epsilon is given, so epsilon is in our hand now. So epsilon is a known quantity. 2 upon epsilon is a known quantity. Take its square root. That is a known quantity, and then choose natural number greater than that by Archimedean property. Right? So see, think logically whether this quantity is well defined or not. You should always worry about such kind of things. If it is not well defined, then it doesn't make sense. And it is clearly well defined because epsilon is already given. And now from that using epsilon, and that's why I said k depends on epsilon. Right? K has to something to do with epsilon. Right? To produce k, we have to use epsilon. Look at 2 upon epsilon and then root of this and then choose k greater than this. So k depends on epsilon. That makes sense, right?
Yes, sir.
Am I right?
Yes, sir.
Right. And now I have chosen k which is greater than root 2 upon epsilon. Now verify that this is a correct value of k. Next, to verify this k will serve the purpose. Right, this k will serve the purpose. What was the purpose? Do you remember what was the purpose? What was the purpose?
Mod of xn should be less than epsilon for n greater than equal to k.
So our purpose was to produce k, and what was the purpose to produce k? After k onwards, all terms have distance less than epsilon from 0. And say avoid using word mod or all these things. So say distance, right? Because we are talking about distance between the terms, right? So you always say distance because absolute value is a distance. Okay, so how to verify this is a required case? So if when we believe that this is a correct k, if you choose n greater equal k, then check whether distance between x and 0 for all such numbers, all such terms is less than epsilon or not. So 2 upon 3n square minus 0, which is 2 upon 3n square, and no matter what is n, this is always less than or equal to 2 upon n square. Right, but what is our n? N is greater equal k, and by choice, what is k? 2 upon epsilon, right? So how we select our k? K greater than root 2 upon epsilon, and I am choosing n greater equal k. For any such n, is it going to happen that distance is less than epsilon? So n is greater equal k, and k by choice it is greater than root 2 upon epsilon. That means n is greater than root 2 upon, right? If I am wrong, just stop me. Ask if you need doubt. Right? What does it mean? N square is greater than 2 upon epsilon. What does it mean? What does it mean? 2 upon n square is less than epsilon. This box. Is this box correct?
Yes, sir.
Yes, sir.
Okay. So if n is greater equal k, can I say that this quantity is less than epsilon?
Yes, sir.
Right. So very good. So therefore, uh, xn minus 0 is less than epsilon for all n greater equal this particular k. What k we have selected? Greater than root 2 upon epsilon. So there for any, we did not select specific epsilon. For whatever epsilon, we are able to produce k. So for any epsilon, we can produce k such that The distance between xn and 0 is less than epsilon for each n greater equal k. And what is the conclusion of this? By definition, limit n tends to infinity of xn is 0. Right? Is it clear?
Yes, sir.
In particular, if epsilon is equal to 2 upon okay, epsilon is equal to 1 upon 100, for example, what is k? Can you tell me what is k?
101.
So k should be greater than square root of 2 upon epsilon. What is this? 200. Am I right? Is it correct? What is 2 upon epsilon?
Yes, sir.
What is 2 upon epsilon? 2 upon 1 by 100, which is, and by our previous formula for, we have actually generated formula for k. And then now you can ask, give me any epsilon, I can give you immediately k, because I have generated the formula to produce values of k, right? And so what is the value of k in this case?
15.
Okay, right. You can choose 15, 16, no problem. Because something is true after 15, then definitely it is true after 16, definitely it is true after 20. Am I right? So not necessary you should select 15. You can select 16, no problem. This will serve our purpose. Right. If epsilon is equal to 3 upon 2000, what is k? You tell me what is k. Right? Uh, Divided by 3, right? No, 4000 divided by 3. Correct?
Sir.
And what is this value? You can easily calculate. 4000 divided by 3. What is it? 1, 3, 3, 3 point something, right? And what is the number which is greater than this? We want natural number. So what is the proper choice for k?
41.
So that you can understand ki what is the square root, and then you can select. So you can choose 42, 50, whatever. If epsilon is equal to 3 upon 127, what is k? Right? If epsilon is equal to 9 upon 1684, then what is k? So you try to find. So, and now do you agree that ki for any epsilon we are able to produce k?
Yes, sir.
Right.
Yes.
What does it mean? If you have 0, you take any distance from 0, whatever smaller, doesn't matter. I can produce k, k onwards, all terms are in this range. Ultimately, what it suggests logically, ki terms are going towards 0. No matter how distance you choose from 0, you can find terms of sequence in that distance from 0. Right. That ultimately suggests that ki terms are approaching towards 0. Right.
Sir, is the value of n also known in the definition?
Value of
N.
which n?
Sir, n of that xn.
N are natural numbers.
Yes, sir. Then if then the can epsilon be equal to xn?
No, no, no. What is my sequence? 2 upon 3 n square. This is my sequence. What does it mean? I am talking about this sequence. What are the terms of this sequence? 2 upon 3, 2 upon 3 into 4, 2 upon 3 into 9, 2 upon 3 into 16. These are terms, infinitely many terms. Therefore, n is a natural number that gives the terms of sequence. Right. What is my aim? Key given epsilon. What is k? That means what is the term here? Right. This is a kth term. Right. This is the first term, second term, third, fourth term. Because this term corresponds to n is equal to 4. This term corresponds to x3 corresponds to what? N is equal to 3. x2 corresponds to what? N is equal to 2. So xk terms corresponds to n is equal to k. And what given epsilon, what is a k? Such that the distance between x and xn is less than epsilon. This is my distance. All terms. What is the k such that all terms after kth term are in epsilon distance from x, right? When I say limit is x, do you understand?
Yes, sir.
Right. So n is just the n is a natural number. So if you vary n, you will get all the terms. But given any distance from x, epsilon distance, what is a kth term? Kth term. Suppose k is 100, then 101 term and all our remaining terms. Their distance from x is less than epsilon. What is that k? That is our question. And that we tried to produce in previous example.
So actually we said it in terms of neighborhood also, no? So like the deleted neighborhood part, does it come in this?
No, not deleted neighborhood. Not deleted neighborhood. So for example, xn is 1. What can you say about this sequence? What are the terms of this sequence? What is the first term?
1.
Right. What is the second term?
1.
1, 1, 1. So this is called as a constant sequence. Constant sequence. Now what is the limit of this sequence?
1 only.
Right. So what is limit of a constant sequence? Right. So limit n tends to infinity of this sequence xn. So limit as n tends to infinity of xn is 1 for all n, no problem. Right. So and this limit is comes out to be 1. Can you prove by definition? Because we are not moving the away this number. So whatever you step you go, ultimately terms are going towards 1 because each term is 1. Right. In case of 1 by n sequence, terms are as n increases, the terms are going towards 0. Therefore, we say that limit is 0 for 1 by n sequence, or in previous 2 upon 3 n square. But here all terms are 1, so there is no movement. All terms are 1, so limit is 1. Using definition, can you verify this? Right, so given epsilon, what is k? Such that right, so this is very fundamental question. What is k in this case?
1.
K is correct. What is k?
1.
1, right? Very good. Because every term satisfies this condition. Right? because what is xn minus 1, or in particular what is x1 minus 1? What is x1 minus? What is x1?
0.
0, less than
1.
epsilon, because we have chosen positive epsilon, and certainly
Yes.
0 is less than every positive. What is x2 minus 1? 0. No problem, right? So can I say that xn minus 1 is less than epsilon for all n greater equal 1? Can I say
Yes.
this? Right? And here we cannot say
Yes.
that key deleted neighborhood, because minus epsilon less than xn minus 1 is less than epsilon for all n greater equal 1, means for all n in fact. So 1 minus epsilon less than xn less than epsilon for all n greater equal 1. But what is xn for all n?
1.
Right? That means xn is belongs to 1 minus epsilon 1 plus epsilon for all n, means what? 1 belongs to 1 minus epsilon 1 plus epsilon for all n. Right, so we cannot say deleted neighborhood, right? We are talking about neighborhood, epsilon neighborhood. Is it clear?
Yes, sir.
Right, so is there any confusion?
No, sir.
Right, so see, work out many problems. Try to do these calculations for many problems. Then only you can understand. Okay, I will give you some examples so that xn is equal to uh, then prove that limit of xn is 2 by 5. Right. For that, okay. What is the sub part? Find k for the following such a that for all n greater equal k. So find k for epsilon, and I will give you particular values of epsilon, and then you try to produce k. Right? You do this epsilon is 1 by 2, 1 by 10, 3 upon 23, 1 upon 2020, 3 upon 2050, 2569. Right, so this is a first step. Second step, can you generate a general formula in terms of epsilon? Right, then find k for general epsilon. Whatever epsilon is given, can you tell me k? In previous example, just go back to the previous example and see. Given any epsilon, what was my k? What was the formula to produce k?
K should be
Do
greater
you
than
understand?
root of 2 by epsilon.
So this gives a more stronger information that k should be greater than root 2 upon epsilon. So logically, what is the procedure? Given any epsilon, can you produce k? For this particular epsilons, we can certainly produce k. But what is in general, whatever, because you are not satisfied if for finitely many values of k, right? As we discussed the example, if you are in 1 by 10 distance, if you are in 1 upon 1000 distance, is it sufficient to say produce k for two values of epsilon? Do you understand the question? Key, suppose epsilon is equal to 1 by 10 and I produce some k depending on this epsilon. Is it sufficient that key limit is x?
No.
No, right? So suppose I produce k for epsilon is equal to 1 upon 5000. Is it sufficient to say that limit is x?
No.
No. Suppose you work out, find k for 100 values of epsilon. Is it sufficient to say that limit is x? Yes.
No, sir.
No, right? Because if you work out, if you produce k for finitely many values of epsilon, that is not sufficient, because as I gave you an example in the beginning, if after that smallest epsilon, you may take U-turn and you come back, you are going towards Mumbai. What is the proof? Given any distance from Mumbai, you have to produce your location so that you are in this neighborhood, in this distance. But for 1 kilometer, half kilometer, or 100 meter, that is not sufficient. You may take U-turn after that and you say that you are going towards Mumbai. So that fails. So for any distance, you should be able to produce your location, whatever distance from Mumbai. So same thing for every epsilon, generate you should produce k for general epsilon. Whatever epsilon doesn't matter, I can produce k. Right? Is it clear?
Yes, sir.
So xn is equal to, okay, fine, k for epsilon such that minus 0 is less than epsilon for all n greater equal k. Right? And I'm giving you some values of epsilon, 1 by 3, 2 upon 151, 3 upon 357, and so on. Find k for these values of epsilon. And then my next question would be, prove that limit is 0. Limit n tends to infinity is 0. Prove that limit of this sequence is 0. That means this the sequence is going towards 0. Question clear?
Sir, can you show the table one more time?
So whatever values of epsilon I have given, that is not special values. You choose any epsilon, 1 upon 5000, 3 upon 7521, whatever want you select, and can produce k. This is just for particular, but for some values of epsilon, producing k is not sufficient, right? And then give general. Whatever is epsilon, I can give you k. So generate general formula. Right. Xn is equal to 1 upon 3n plus 7. Prove that limit of xn is 0. Now, do you understand what is meaning of xn limit is 0? How to prove this?
Yes, sir.
Prove that. Okay, so you work out these examples in detail, what we discussed in the previous problem. In similar manner, you work out these examples, then you will be comfortable with this. Any doubt?
No, sir.
Right, so everything is clear?
Sir,
Yes, sir.
excuse me, sir.
So, sit down, work out this calculation in detail and what is the meaning of definition. So, recall definition again and again. What basically we are doing, given epsilon, can you produce k? This is the main problem. Right, we are successful in producing k for epsilon, we are done. Right, and you have to show it. Okay, if I take this epsilon, I have produced this k. And this k is the purpose. That's the main issue. Once you are successful in doing this, you are through. Right. So, any doubts, any difficulty? So that see, if you come today, you just work out this calculation so that next time we'll go to the next topic. We can go ahead. Otherwise, we'll remain on the same point.
Excuse me, sir.
Yes.
Can you explain a constant sequence one more time?
Constant sequence.
One more time, I didn't really understand.
Okay. So, what is a constant sequence? So, xn is equal to alpha for all n belongs to n. That means what is my sequence? Every term is same as alpha, right? Alpha is a constant. That means all terms. So what are the terms of x1, x2, x3 and so on? These are the terms. But what is x1 is alpha, x2 is alpha, x3 is alpha, x4 is alpha. All terms are alpha. Then what is the limit of xn? When I say limit means limit as n tends to infinity. That means limit as n tends to infinity of alpha. What is limit? Same number. Correct? Why? By definition of limit, given any epsilon, I will choose k is equal to 1. Then xn minus alpha. What is alpha minus alpha? Because each term is alpha. So this is 0 less than epsilon for all n greater equal 1. Because every term satisfies this condition. Is it clear?
Yes, sir.
Right. So every term is alpha and therefore limit is alpha because alpha minus alpha is 0 less than epsilon. Whatever positive distance you select, every term satisfies this condition ki xn minus alpha is less than epsilon. In fact, it is 0.
Okay, sir.
Correct? Right. So anybody else?